Okay, welcome back. We're still in 4.6 with the distance problems, and I'm working on the second problem here out of this packet. We're using this packet because it's easier. I don't have to write down all the problems, the words, and you have them listed right there. So if you haven't done so, which I hope you have, because on the first one I said to go download it, make sure you download this whole packet. It's very helpful. It's got a lot of good things in there for you. So we're here on the second one. It's talking about a car and a train. So whenever we have distance problems, we always start with this chart where it says rate times time equals distance, and then we're going to draw a picture, and then we're going to find our equation. You always need to have those things. So if you use this chart and draw the picture, it's going to make life a lot easier. So we're talking about a car and a train in this problem, and it tells us that the car is driving 56 miles per hour and the train drives 42 miles per hour. It says how far from the starting points are the car and the train, and we're going to use this following chart to figure it out. So the thing it tells us is that the train had a 1 hour head start. What does that mean to have a 1 hour head start? That's mean that if the car and the train are here at the train station, the car stays and the train drives for an hour. So if the train left at noon, what time would the car leave? Did the car leave at noon? Did it leave at 11 or did it leave at 1? It left at 1 because the train had an hour head start. So it left an hour before the car. So we just need to make sure we can see the difference of an hour here. We can either say that the car left at T and this left at T plus 1 because the train is traveling for an hour longer than the car. Another way we could have wrote this, and it doesn't matter which way, you just need to make sure you have a differentiation between there by an hour. This one could be T, and this is T minus 1. So see, there's still an hour difference. If this was 5, this would be 4. It's still the same because T and minus 1. So it doesn't matter which one, you just need to be consistent about it. So it just makes sure that you show that they traveled an hour difference between them. So now how do we find I'm just going to go ahead and go and find our distance here. How did we find our distance for the car? We multiply rate times time. Well, this time is T minus 1. So we need to multiply 56 times T minus 1, or 56T minus 56. It's rate times time equals distance. So the same for train here, we're going to say 42 times the time, which is 42T. We always get our distance that way. It's always going to come from here, okay? So now the question is, where's our equation? It tells us that the car overtakes the train. What does that mean? That means they're starting here. This is our starting point. And to overtake, what's another word for overtake is to pass. So here's our car, here's our train. They start at the same spot. The train has a 1 hour head start. He's driving along here, and he keeps going. And then an hour later, the car starts. Well, at first they're like this, right? There's a difference between them. But to pass or overtake, that means at some point their distances have to be equal. If they overtake each other, that means that they have the same distance at an instant. And that's what we want to know. When will they have this? When will the car overtake the train? So that tells me that the car distance is equal to the train distance. Okay? The car distance is equal to the train distance. Now, what was our car distance? We look right up there in our chart and we have it. It's 56T minus 56. 56T minus 56 equals, what's the train distance? 42T. Now we have our problem. We have our equation. There's our equation. We have our chart. We filled it in. We have our picture. And we have this is when they overtake. I'll label that for you so if you need to see. Car overtakes train or passes. Okay? So now we can solve this. We have 56T minus 56 equals 42. You go ahead and do that real quick. Hit pause and do that, and then you can be right back. So welcome back. We're going to solve this now. We can subtract 56T from both sides. And we have negative 56. Don't forget that that's a negative. A lot of people change that to a positive there. but that's still a negative 56. And then we need to subtract these two. 2 from 6 would be 4, 4 from 5 would be 1, and it's a negative because negative 56 has a larger absolute value. And I divide by negative 14, and we have 56 divided by 14, and what would that be? Let's see. 4, 5 would be 5. 5 times 4 is 20. Nope, can't be that. 5, that'd be too big. So let's try 4. 4 times 4 is 16. 4 times 1 is 4. Plus 1 is 5. Yep, 56. So, excuse me, 4 equals t. So is that what he asked for? Did he say when will they? Let's double check. It says, no, it's not asking for time in this one. It said how far from the starting points are the car and the train. So I found an answer. This is where we have to be very careful because I found that the time was going to be 4 hours. 4 hours for what? What does the T stand for? The train travels for 4 hours. The car travels for 3 hours because it's 1 less. Now it's asking how far from the starting points. We want to know what this is, what this distance here is. We can either find it by using the train's distance or we can find the car's distance. Since they're equal, it doesn't matter which one. So I need to just come over here and I need to go, the distance is equal to 42 times 4. 4 times 2 is 8, and 4 times 4 is 16. So 168 miles, the car will overtake the train. Okay, let's see, is that all on the screen? Yep, it's all on there. All right. So any questions on that? Oh, we're in video, right? I'm used to saying, is there any questions? I must ask that probably 50 times a class period. But if there are any questions, just shoot me an email right there and I will answer it. Just make sure you reference which video, which question, so I can I know what you're talking about. Okay, so that was that question. We'll pause there and start with the next video in a minute. See you in a minute.